Okay, so now let's see how we continue. What's the next thing I want my game of life to do with my universe? What we have left is two things in this class, two methods that I have to implement. The first one is running, the second one is render. I discussed before that I would like to, in the future, somehow let the player, the user, control whether the game is running or stopping. But for now, the most trivial implementation of this interface is just to always return true, since the game of life is not really a game that is stopping at some point. I don't really mind that it's running forever and I have to kill the process in order to stop the game. So for now I'm going to write a test which says is always running. And for that test I'm going to create a new game of life with actually no universe, because I don't need a universe. This is my unit on the test. Then I have my universe invoke is running, and I'm going to assert that this is true. No, not assert that, but assert true. I see a tiny indication of a smell here that I pass in a null object here for the universe. Not a null object, but null, which actually means that part of the behavior of the game of life implementation does not need the universe parameter to the class's constructor. But this is kind of a problem when you use general purpose frameworks, that sometimes interfaces are more general than what you actually need, and for the concrete implementation you may not need some things that you could use, for example, in a more complex game where is running actually depends on the universe state, which could obviously be the case in my opinion. The same is actually true for the tests we wrote before, which is this update call here and the input handler being of type void, because, or it's not the input handler being of type void. That's why this works, by the way. It's been a long time ago that I wrote this. But the input is of type void, because there's actually no input to the game of life after you started it. So for this specific case, I'm going to use void and null here. But since the game loop framework, in a sense, supports any TM kind of game, which includes games with input, I have this in the interface of the framework, and I somehow have to deal with it being there, which in this case means to replace the type parameter by void and the actual parameter by null. This is not quite beautiful, and I could change this, but as I said, I'm going to try to treat the game loop framework as a black box framework that I got from somewhere else, and see where this leads me. And one of the drawbacks of doing that, of using a separate framework, is that sometimes the actual requirements I have for my current application do not quite match the requirements that the implementer of the framework thought of, as in this case, where I have parameters I don't actually need. Anyways, coming back to the test I was about to implement, I think the test is pretty much done. Let's run it. It's failing because is running returns false, and the implementation to fix that is easy as pie, I guess. Tests are running. So let's do something I actually forget about, which is checking in stuff. And no, I should check in more often. That's what I was thinking about. I should have checked in after the first test passed, but somehow I forgot about it, and now I have actually multiple changes to my Conway's Game of Life implementation, which I'm going to put into one commit. I know that I could pull them apart via staging, but I'm not really willing to do that now. So I'm going to live with that. I'm going to try to commit more frequently in the future. Micro commits for the win. So what did I do? We can now can we actually run the game? We can run the game, right? But we can unfortunately not see anything because there's no output yet. Our game can now run, and there's the treacher's word telling me that I did multiple things in one commit. Our game can now run and update its universe. Okay, committed and done.